All right, let's get introduced to polar graphing. Let's just go over a few basics. This is a comparison. The regular coordinate grid has an origin with two ordered pairs. The polar grid just has a pole. It's in the center. It's kind of like the origin. You have two axes on the coordinate grid. You only have one axis on this polar grid. We have a X and a Y independent and dependent. Over here, it is kind of swapped. If you notice, the angle is independent. The distance from the pole is dependent. So we're going to look at this component first. Only one way to get 1 point on a coordinate grid. There are 4 ways to get a single point on a polar grid. So let's talk about this grid because it's really the unit circle in disguise. So look, if I count around this circle, it's really all cut into 6s. There's 3 sections, 3 sections, 3 sections, 3 sections. So we know that this is always 0 pi and 2 pi, just like the unit circle. Then we have 1 pi over 6, 2 pi over 6, but you know that simplifies to a third. This is your top part of your unit circle. We know this is pi over 2. So 1 over 6, 2 over 6, 3 over 6. Here's 4 over 6, which is 2 pi over 3. Here is 5 pi over 6. There's regular pi, that's 6 over 6. Here's 7 over 6. 8 over 6, but we're going to write 4 pi over 3. Here's 9 over 6. It's also the bottom of the circle. We know that's 3 pi over 2. And then over here, let's see, that was 7 over 6, 8 over 6, 9 over 6. That's 10 over 6, but of course that's 5 pi over 3. Then we have 11 pi over 6. Notice I went in the normal order, which is counterclockwise. But you can also, as you know, you can go in the opposite order, which is clockwise. And let's just kind of review that real quick. So we're still going to count by 6s, but we're just going to go negative. So there's negative 1 over 6. So this is the same as negative pi over 6. Negative 2 over 6, which is the same as negative pi over 3. This is negative 3 over 6, which is the same as negative pi over 2. So negative 1, negative 2, negative 3, negative 4 over 6, which is going to be the same as negative 2 pi over 3. Here's negative 5 over 6. Here's negative 6 over 6, which is just pi. Here's negative 7 over 6. Negative 8 over 6, but let's write 4 pi over 3. Negative 9 over 6, which is negative 3 pi over 2. Negative 10 over 6, which of course is negative 5 pi over 3. And then here's negative 11 over 6. All right. One more thing that's kind of hiding out, the corners. If you look through this packet, every time you see a polar grid, it's always in a little square box because the only thing that's missing are the fourths, pi over 4. And pi over 4 is not really part of a polar grid, but we need it because it's part of the unit circle. And your fourths cut this square picture in half on the diagonals. So please go ahead and draw 2 diagonals across because that's going to represent the fourths. So this is pi over 4, 2 pi over 4. Here's 3 pi over 4. 4 pi over 4. Here's 5 pi over 4. And then, of course, is 7 pi over 4. And we can go in the opposite direction of that also, but I'm just going to go ahead and keep the counterclockwise here because I don't want it to get too cluttered when you first look at this. One more thing I want to talk about. So everything that I just labeled has to do with radians. Now what we're going to talk about is R, which is the space away from the poles. That's the circles. If you notice, if I go one place away from the pole, that's the innermost circle. Here's another circle that's 2 places away, 3 places away, 4 places away, 5 places away, and it goes on. And notice it goes all the way around. That's why we only have one pole, because the distance makes a circle. All right, let's go ahead and start plotting.